All right, guys, I'm going to be going over 7-2 quadratic formula. So we have the quadratic formula right here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you can always use the quadratic formula to get the solutions to any quadratic equation, whether those solutions are real numbers or imaginary numbers. The thing to keep in mind is you want to make sure your quadratic is in standard form before you use the quadratic formula. So this one is, right, ax squared plus bx plus c equals 0. That's standard form. So I'm going to go through this one a little more detail in terms of the setup and identifying the parts, but after that I'll go a little faster. This is number 3 from that page. All right, so in this case, the leading coefficient here, right, if there's no number, there's always a 1. So our A is going to be a 1. Right here, the next one is a B. That's our B. Since there's a minus in front of that, our B is actually going to be a negative 5. And then the final one, the constant term, is the C. That's 3. So the quadratic formula is done simply by taking these 3 coefficients from our standard form quadratic equation and plugging them into the quadratic formula. It really becomes a matter of carefully simplifying this until you arrive at your 2 solutions. So I'm going to go ahead and do that. So we get x is equal to the opposite of b, which is going to be positive 5, plus or minus the square root of b squared, so negative 5 to the second power, minus 4 times a times c, all that divided by 2 times a, 2 times 1. As you're going, you might like evaluate these pieces before, instead of writing them all out. Instead of writing negative 5 squared, you might just do that in your head as 25 just to speed up the process. But right now, I just wanted to show the whole thing. Okay, so we get 5 plus or minus the square root of 25 minus 12 all over 2. 25 minus 12, that's going to be 13. So we get x is equal to 5 plus or minus the square root of 13, all divided by 2. All right, so now at this stage, we have a couple options. We could kind of call this done. There's no further simplifying that I could really do here. This radical does not simplify at all. There's no way to divide this 2 through or find any common factors or anything. So we could go ahead and say this is the answer. 5 plus the square root of 13 divided by 2, and 5 minus the square root of 13 divided by 2. That would represent our 2 answers. We could take this one step further if we wanted some approximations. So I'm going to go ahead and get a calculator out and do this really quickly. So 5 plus the square root of 13 divided by 2. So when I use the plus, I get x is equal to approximately, so I mean, these approximately, x is approximately 4.30. It goes further than that, right? But I'm just going to use 2 decimal places. And then let me go ahead and get the other one when I do this as a minus. So 5 minus the square root of 13 divided by 2. I'm getting 0.697. So I actually would round up to 0.70. So these would be my approximate solutions if I wanted some approximate numbers for whatever reason, depending on why am I solving this equation. And this would be an exact solution. These would represent my exact solutions without any decimal approximation. Now, you'll probably notice I used x when the variable was p. That's just a mistake. I shouldn't have done that, but oh well. We could say that p is equal to this and p is equal to that. All right, I'm going to go ahead and clear this and pick a different problem to go over. Okay, the next one I'm going to do is this. This is going to be number 9. We have 3x squared equals negative 2x minus 1. All right, so this is a quadratic equation as well. It's not in standard form. That's the first thing that I'm seeing about it. So before I do anything using the quadratic formula, I would want to change this up and put it in standard form. So I'd get 3x squared plus 2x plus 1 equals 0. All right, so now it's in standard form. I have my A, I have my B, and I have my C. So I am going to go ahead and use the quadratic formula now. And x is my variable, so I won't be making that mistake again. So it's the opposite of b, -2, plus or minus the square root of b squared. So that's actually 4, right? 2 squared is 4. Minus 4 times a times c. So 4 times 3 is 12, times 1, still 12. All that divided by 2 times a. So 2 times 3 is 6. So notice how I did that a little different than the last time. It's going to save me just a little bit of extra writing that I won't have to do. Okay? So -2 plus or minus the square root of -8 over 6. All right, so looking at this, I can see that I have a reducible radical. The square root of 8 is reducible, and also it's negative. So I'm actually getting some imaginary solutions to this particular quadratic. So I'm going to go ahead and simplify that. 8, remember, is just 4 times 2. 4 being a perfect square, so I can simplify this a little bit. So I get -2 plus or minus 2i root 2. All that divided by 6. All right, so now since this is an imaginary number, I'm not going to be able to get like decimal approximations for like sort of the approximating the exact solution. I could use decimals, but with imaginary solutions, we rarely do that. There's not really a good reason to do so. So I'm going to keep this in exact form, but there is one further step that I can do. All of these coefficients or whole numbers here, 2, 2, and 6, all of those are divisible by the same number. They're all divisible by 2. So by doing that, I'm going to get -1 plus or minus 1i. I'm just going to write that as I root 2 over 3. Right? I divided all of these by 2. And this would be my two exact solutions. -1 plus I root 2, -1 minus I root 2 over 2. All right.